We're going to build a coronavirus tracking app, and we'll do it in the style of a stock trading app called Robinhood. Coronavirus has dramatically impacted life around the whole world for months now, and all the data indicates that it will continue to impact our society for months to come. As software engineers, the best thing we can do right now is to build tools to understand and display the data related to COVID-19. This topic is close to my heart because my sister actually contracted coronavirus, and she was in pretty bad shape for a few weeks. Thankfully, she's recovered now, but that experience motivated me to build this project. Understanding the spread of coronavirus is critical to understanding what we can and should do to respond to it. Unfortunately, Google Play has prohibited all apps related to COVID-19 unless they're from a government or medical institution. So I decided to build my own COVID-19 tracking app, and I'm going to show you how to build it as well. Our app uses the same UI components as the Robinhood stock trading app, and the whole app is going to be written in less than 200 lines of Kotlin code. Let me do a demo of the app. The purpose of what we're building is to be able to quickly see trends around the growth of coronavirus, both at the national level and state level. So by default, when we open up the app, we're displaying the number of positive COVID-19 cases nationwide or across the whole US. And I have the ability up here to toggle between the number of negative cases per day, number of positive cases, or number of deaths per day. And you'll notice that the graph animates in. Down here, we have the ability to toggle between the different timescales. So maximum means display all the data we get back from the API, which is generally starting from around March. 1 month means the most recent 1 month of data, and 1 week means most recent week of data. By default, we're showing maximum. The other option I have is to actually scrub on the chart, on this line chart. And you'll notice that we update the metric, the individual metric number shown down here. It animates in, and it displays the exact quantity of this metric on that day. So on April 25th, 2020, there were roughly 1,800 deaths in the US. I also have the ability to dive into a particular state. So for example, in California, we can see that there's been a recent increasing trend in number of positive cases per day in California. And the same things apply. I could also dive into the number of negative cases in California or number of deaths. And if I wanted to look at a particular day, I can scrub over the graph and you can see how the text animates in down here. If you keep watching, you'll learn how to build exactly this, step by step. The data for our app is coming from the COVID Tracking Project, which is the most reliable data source I could find for getting daily updates on the number of coronavirus cases. Two of the core components in our application, this chart, which is called a Spark chart, along with this changing text view called a ticker view, both of them are coming from open source projects from the Robinhood app. Both the Robinhood app and our app are displaying the change of a metric over time. Stocks versus coronavirus cases. So there's a natural fit to using the same components that they're using in the Robinhood app. And Robinhood is considered one of the best designed Android apps out there. So there's a lot to learn from what they're doing. I hope you're as excited as I am to start building this project. In the next video, we're going to fetch data using Retrofit from the COVID Tracking Project API. I'll see you then. Our goal in this video is to talk to the COVID Tracking Project API in order to retrieve the data that we need for our application. The way we'll go about doing this is by using the API created by the COVID Tracking Project. Our phone or our application is the client, and we're going to be making a request to the COVID Tracking Project and getting a response which contains the data. We're going to be making a GET request on this particular URL, api/v1/us/daily.json, and what that represents is we want to retrieve the daily data of the number of coronavirus cases nationwide. And the COVID Tracking Project will respond with JSON data. And that JSON data will contain the metrics for each day, up until the most recent day. In addition to getting the data nationally, we'd also like to be able to get the per state data for coronavirus. And in order to do that, there's one more endpoint in the API that we'll need to hit. And that will give us back a list of the data per day per state. Now we have an idea of what we're trying to do, we can start the implementation. We're going to use a library called Retrofit on Android, which makes working with APIs really straightforward. What I have here is a totally empty Android project. So if I run it now, you'll see the emulator showing the Hello World application. The first thing I'm going to do is go into the Android manifest file. And because we're talking to an API over the internet, we need the internet permission in our application. Let's start typing uses permission internet. The next step is to include Retrofit in our project. So what I have open here is the official site for Retrofit, which is a library developed by Square. And I'm going to go to the download section so we can figure out how can we include this library into our project. So here you can see it says for Gradle, which is what we're using, you need to include this line. I'm going to copy this, and notice that it says insert latest version here, so we're going to fill that in later. But I'm going to go into our project and go into build.gradle, and make sure you're going into the build.gradle, which is located in the app module. And then in the dependency section, I'm going to add one more dependency, which is for Retrofit. In order to get the latest version, I'm going to open up GitHub and tap on releases. And you can see that the most recent release is 2.9.0. So let's replace this with 2.9.0. One more thing that you'll need in order to use Retrofit is a converter. So if I tap on the section around Retrofit configuration, the converters are used by Retrofit to translate the API response into a model that we can work with in our application. And I'll talk more about what that means later on. We're going to use JSON for this. So I'll copy the dependency for JSON, go back into Android Studio and paste that in with the same version number as what we used for Retrofit. Finally, the last thing we'll need to do before we can build our project is instruct Gradle to use Java 1.8. And the reason for this is because more recent versions of Retrofit use a component which uses a Java 8 feature, which are lambdas. So in order to enable Java 8, we go up into the Android section of the build.gradle file, hit enter a few times, and we're going to add a section here called compile options. In this section, we're going to have two lines, one for source compatibility and the other for target compatibility. And for both of these, the value was going to be Java version 1.8. At this point, it's worth making sure that we haven't screwed up yet. So I'm going to tap sync now, and we see a sync success. The next thing is let's build our project, and we don't expect any UI or functional changes, but we should still be able to build the project and see Hello World. Right. In order to use Retrofit, the first thing I like to do is define a new file, which is an interface that Retrofit will consume in order to talk to our API. The way that works is we're going to create a new interface file in the same directory where main activity is located. And let's define a new file here, a new Kotlin file, and call this COVID service. The idea of this COVID service interface is that we're going to have one function defined here for each endpoint in the API. So like we talked about earlier, there are two endpoints that we're interested in. One, which is for getting the national data per day, and I'll call that get national data. And the other is for getting the per state data, and I'll call that get states data, plural because we're getting the data across multiple states. The way Retrofit works is that we need to add in a corresponding annotation for each method defined in our interface. So for example, we're doing a GET request on the endpoint us/daily.json for getting all the national data. Next, we'll add a return value for each method that we've defined. Retrofit and JSON will automatically take the JSON data returned from the API and turn that into data models that we can use in our application. This is going to be enclosed in something called a call object that Retrofit gives to us, and then our job is to define the data class that we'll actually be using in our application, and I'll call that COVID data. So we're going to have the return value be a call, which is a list of COVID data, because there'll be one element in the data we get back for each day. The return value for the other function in our interface is going to be the same, a list of COVID data, and I'll show that to you later. And the annotation is going to be similar again, except for the endpoint is states/daily.json instead of US. One thing that's worth noting about this API, which is really nice, is that there's no authentication or API key that you need in order to use it. So now let's define this data class COVID data. I'm going to again open up the project tool window, and let's define a new Kotlin file which defines COVID data. COVID data class is going to be a data class which represents the data that we care about from the JSON object in the API. We're going to use an annotation called serialized name, which defines the mapping of the JSON key to the variable that we want to map it to in our data class. So for example, there's a key in the JSON object called date checked, and we're going to map that to a string, which is also called date checked. And I'm going to show you that in the actual JSON result that we get from the API. So what I have here is the documentation for the COVID tracking project API. And if you scroll down, you can actually see the different endpoints available in this API. The data that we're getting back right now is historic US value. And we can issue the GET request in the browser in order to dive into the JSON data. And you can see the data that we're getting back is enclosed in this JSON array. That's what these square brackets mean. And inside of this JSON array are different JSON objects. This represents 1 day worth of COVID-19 metrics for the US. The COVID data class that we've defined in our project represents one JSON object here. And the attribute that we've already parsed out is this one called date checked. So we're actually parsing out this string. We're going to ignore a lot of the attributes in the JSON object, but because we're interested in the change per day, the attributes we are going to parse out are negative increase, positive increase, and death increase. In addition, when we are querying for state data, we're also going to care about an attribute called state. So I'm going to include one attribute in COVID data for each of the JSON keys that we just talked about: positive increase, negative increase, and death increase. In addition, we're also going to have one more key for the US state that this data represents. One optimization we can do is if the serialized name exactly matches with the name of the variable, we can get rid of the serialized name annotation. And that's the case for each attribute that we've defined. I'm going to go ahead and delete the serialized name for all of them. One thing we should fix here is that the positive increase, negative increase, and death increase won't be of type string, but they'll actually be of type integer because they represent the number of new cases found in each of these categories. So now we've defined the COVID data class. We can go back into COVID service and we can see that the red underlines have gone away. Now we can put all the pieces together in main activity. The onCreate function will get called by the Android system when our application boots up, when our activity is being created. At that point, we want to make the API request to fetch the national data so that we can display a chart on the screen showing it. We'd also like to get the state data because as soon as we get the state data back, we can populate our dropdown, our spinner, so the user is able to drill down into a particular state. Here's where we're going to use retrofit. The first thing we'll do is create an instance of JSON using the JSON builder because we're going to need that to create an instance of retrofit. We use the retrofit builder, pass in a base URL, which I'm going to do shortly, and add in a converter factory where we pass in the JSON converter factory and pass in the JSON object, and then we can call .build. We can now use the COVID service class that we created in order to create an instance of the COVID service. And on this, we can call the methods that we had defined. And I'll get to that in a little bit, but first, let's go back and define the base URL as a constant up here. So in COVID service, we defined the end of the URL, which is us/daily.json. And if we go back to the browser, you can see that that basically captured this last portion of the URL. The base URL will be everything except for that, which will be this portion in the beginning. So I can capture that, put it here, and let's add this in our retrofit builder. Let's go back and uncomment this COVID service I get national data. And I mentioned how in COVID service, the return value is not the model data directly, but something which is wrapped inside of a retrofit call object. And the reason for this is because of the asynchronous nature of doing anything with network calls. So we get back this call object because that is how we get notified of the success or failure of our API request. So on the call object that we get back, we'll enqueue a callback. And this callback will be parameterized by a list of COVID data. So we're going to copy that in. We can now override the methods that are required as part of the callback. So if I tap on the red light bulb, we can have Android Studio help us to implement these members. There are two methods, onFailure and onResponse. We'll override both of them. And in onFailure, all we want to do is log an error. Something went wrong with the API call, so we're going to put a log.e, which means log at error level, put the tag, and then indicate onFailure, and also include the throwable T, which is included. So let's define the tag at the top of the file. And my convention for that is always to have the tag name be the class name. For the onResponse method, the first thing we'll do is simply log at info level that we entered into the onResponse method. And we'll also include the actual response that we get back. Next, the body of the response will contain the list of COVID data that we should have been able to parse from the API. If this data, which represents the national data, is null, that means we got an invalid response from the server, and we should log something at warning level, so log.w, and just indicate that something went wrong. Once we've gotten past this if statement, we know at this point that our data is valid. What we'll do here is save the national data into a member variable which is accessible throughout the whole main activity class. So I'm going to define national daily data and define that as a property on main activity. And this is going to create for us a late init var national daily data, which is a list of COVID data. One important point here is that the data we get back from the API starts with the most recent data. However, for graphing purposes, we'd like to start our data with the oldest data first. And so we're going to call national data.reverse in order to get the proper ordering. For now, the only other thing I'll do in this method is add a log statement which indicates that we're going to figure out in a subsequent video how to take this national daily data and display it in a line chart. To finish up this video, I want to also fetch the state data and then validate that this is actually working. What we've done so far is used retrofit to talk to the API and automatically convert the JSON data we get back into a class we defined called COVID data, which includes attributes such as a date of when this data is relevant, number of positive cases, negative cases, deaths, and when we talk to the state endpoint, we also want to know the state that this data is relevant for. So I'm going to represent this in this light orange blob, which has COVID data inside of it, and it contains a particular date. What we just did for the national daily data is we reversed the order of the list that we got back from the API. So the oldest COVID data is at the front of the list and the most recent is at the end of the list. So a similar logic applies for the state data, but there is a wrinkle because all the state data is combined in one large list. We'll get all the data for all states from May 1st, then May 2nd, and so on and so forth. However, in terms of being able to graph the data, all we really care about, for example, is being able to retrieve all of the data relevant for Alaska. And so what our job is to take this big list of data and pull out all the data relevant to Alaska and put that into a separate list. So the idea is that we're going to take this big list and break it down into a map. And that map will have a key of the state, and the value will be all the COVID data relevant to that state. So with that understanding, now we can define the state data. So I'm going to do something quite similar. So I'll say COVID service dot get states data and queue it. And this is actually going to be quite similar. So I'm going to initially just copy all this. And we're going to leave the log messages here, but instead of calling the return value of response.body as national data, this should be called states data. Similar to what we had before, we first want to reverse the whole list we get back, but then we want to group this large list down on a per state basis. We're going to call this nice group by method in Kotlin and pass in the argument that we want to group by. And that'll be the state attribute of every COVID data object. So this is actually going to return to us a map rather than a list. So I'm going to call this per state daily data, and then we're going to create a property inside of main activity. So again, this property can be accessed throughout the whole class, which we're going to use in subsequent videos. And this is a map between a string, which is a state, and a list of COVID data, which is the chronologically increasing COVID data over time. Once we've computed this per state daily data, the next thing is we'll want to update that dropdown or that spinner with the state data. So that'll happen in a later video. Before we try this out, the last thing I like to do is make one small improvement. If you go back to COVID data, you'll notice that this attribute date checked is a string. However, in order to do computation and make it easier to display this date in different ways, we would actually like to have this date checked be of type date, Java util date, rather than a string. And so In order to make that happen, I can define it as a date here, but we need to pass in another method in the JSON builder. So that JSON will know how to convert the date string and turn it into a Java date object. That can be done by calling this method setDateFormat, and you pass in a pattern. The pattern that the API that we're working with complies with is the following. So with that, we should be able to properly parse out dates. All right, so now we can finally try this out. What I'm going to do to validate that we have something working is go into the onResponse method, and where we have a log statement, once we've computed the national daily data, let's put a breakpoint right there. And now, instead of running the app like normal, hit this button for debug app. So as soon as our program installs and we get into this onResponse method, our program should halt execution at this point. And so you can see that that happened. Here, we can take a look at what is the value of this variable, national daily data, that we just computed. So you can see that the size of this list is 134, which is sensible because that means that we have 134 days worth of data. And if I expand this, we should ideally see all of this sorted chronologically. So the oldest day is January 22nd, January 23rd. So it is ordered, which is great. And it goes all the way up until the most recent day. So this gives us confidence that we are able to parse all the data properly. And you can also see the other values like positive increase, negative increase, death increase. Those are also being parsed out properly here. Now that we have the data which will power our whole application, in the next video, we're going to build out the UI which will display the chart and the metrics. If you like what you've built so far, drop me a like and hit the subscribe button so you know when the next part will come out. See you in the next video. Our goal in this video is to update ActivityMain.xml, which defines the UI for our application, and update it to include the different components that we'll need for our coronavirus tracker. Once we've done that, in the next video, we'll be able to wire things together and actually have the data that we parsed out in the last video together with the UI component that we add in this video and be able to show something on the screen. Taking a look at the final UI of our application, there are a couple different UI components on the screen. At the top, you have the label for this dropdown, and then you also have a dropdown which is called a spinner on Android. For the purposes of this video, I'm going to ignore that spinner and just have the state text view shown there. Below that, we have something called a radio button group. And the radio button group contains 3 different radio buttons. And the idea of a radio button is that it acts somewhat like a normal button, except for you can only have 1 out of those 3 buttons in that group selected, which makes sense because we only want to be able to graph 1 of these metrics in our line chart below. Below that, we have a line chart, and in particular, this is called a Spark chart, and we'll talk about how to integrate the Robinhood library to include this. Below that, we have 1 more radio group, which has 3 radio buttons, and then finally, at the very bottom, you have 2 text views. One which is for the date of what metric is being shown. And then to the right of that, we have the metric corresponding to that date. Here's the default activity main that comes in with any empty project. The first thing I'm going to do is delete the default hello world text view, and instead bringing over 1 more text view. And for now, I'm just going to go into the design tab. We're going to toggle between the design tab and code tab quite frequently. And just to give myself more room, I'm going to open up the design tab and make that the only thing shown on the screen. So we have this text view on the UI. I'm going to call this TV, an ID of TV select state. Give this a text of state, and then have it be 16 dp from the top and left. Let's also make the text larger. The text appearance large. Next, I'd like to bring onto the screen a radio button group. So I'm going to go into the button section and bring over a radio group, and then have the width of this radio button group be match parent, the whole width. Let's zoom in a little bit. Have this be constrained to the bottom of the state text view. And then inside this radio group, we want 3 radio buttons. So I'm going to take the radio button and drag it inside of the radio group in the component tree. The first radio button will be radio button negative. This will have a text of negative. And also let's make the layout width wrap content rather than match parent, so it shrinks. Let's copy over this radio button 2 more times. So we'll have one more for radio button positive. The text will be positive. And then one more for radio button death. In order to have these radio buttons be horizontal rather than vertical, we need to set the orientation attribute of the radio group. And it looks like the width here should also be wrap content. Same as this. Wait, and then also we want to center the contents of the radio group inside of it. So I'm going to select the radio group one more time and set the gravity attribute and have the gravity be center and then apply. So now you can see that it is in the center both horizontally and vertically. Below this radio group, we'd like to have a line chart which shows the data on a per day basis. So to do that, we're going to use a library from Robinhood, an open source library called Spark. And this is a library to show a simple Android Sparkline chart view. So if you scroll down to the very bottom, then we can copy over this line that we're going to add into our Gradle build file. I'm going to open up the build.gradle file, which is located in the app module. Add that in, and then tap on sync now. While that's syncing, let's go back to GitHub, and we can see how to use this. There's a section here about usage. So all we need to do to include this Spark chart in our application is add the Spark view to the layout. Then going back into Android Studio, we can open up the activity main.xml file, and to add the Spark view, I'm going to go into the code tab. So if we can just start typing Spark view here, and then Android Studio will help us with autocomplete. The width will be match parent because we want it to take up the whole width of the screen. And the height, for now, I'm just going to hard code in 150 dp, and we'll change that later. One thing we need to do also is we're going to position the Spark view vertically below the radio group above it. So I added this ID on the radio group called radio group metric selection. So now we can say the top constraint is to the bottom of the radio group metric selection. We'll also give the Spark view an ID of Spark view. So let's see what this looks like in the design tab. So you can see that we have a space allocated for the Spark view. So below the Spark view, we have one more radio group. And this is going to be vertically positioned below the Spark view. We'll give this radio group an ID of radio group time selection because it'll be used to select the time range of the Spark chart. We'll add a 16 dp top margin on the radio group. And then we're going to do something very similar to what we had before, where we add in 3 radio buttons, update the text and the ID, and position them so that the radio group is horizontal. The 3 timescales that we're going to allow the user to pick from are the most recent 1 week, most recent 1 month, and the maximum amount of data that we get returned from the COVID tracking project API. As of today, the max will typically be a period of around 4 or 5 months because we start getting data back from the API around January or February. The last thing we need to do to complete our basic layout is add the 2 text views at the bottom of the screen. And these will be relative to the bottom of the parent or the screen and not relative to the elements above it. So we'll drag out a text view, have this be 16 dp from the left end of the screen, and constrain it to the bottom. And let's also give this a height, a hard-coded height of 80 dp. This will be a text view for the date label. And let's change the text appearance a little bit to make it body 1. And let's have one more text view, which is also 80 dp tall, the same exact height. And this text view is going to contain the metric value. We'll say TV metric label. This is going to be relative to the right end of the TV date label, and it'll be to the bottom of the parent. The gravity for both of these text views is going to be center. And this text view is going to extend the whole remaining width of the screen, which is not taken up by the first text view. And let's provide some sample data for each text view. For example, this metric, let's get rid of the text attribute and let's use the tools namespace here, which is this wrench text. And let's put in a sample data point of 4,354 just to see how it might look. Let's make this text bigger. Let's see, display 1 as a text appearance, so it becomes a lot bigger. And then for this text view over here, let's also put in a sample date, May 30th, 2020. Our goal now is to have the Spark view take up all of the height remaining in the screen once all the other widgets are placed. So the way we'll do this is actually allocate the widgets above the Spark view and below the Spark view and have them be glued to the top or bottom of the screen. So rather than having this radio group be relative to the bottom of the Spark view, I'm instead going to delete that constraint, the top constraint, and have that instead be to the top of the bottom components that we have, like that. Now I'm going to set the bottom of the Spark view to be the top of this radio group. And instead of hard coding the height to be 150, now we can just say match constraint, and that should now fill up the Spark view to be all the remaining height. So now we have completed the basic layout for our COVID tracker. In the next video, we're going to go back into main activity and fill out this to-do. So we're going to get rid of this to-do and actually reference the Spark view that we put on the layout and populate it with the national daily data that we parsed out from the previous video. I'll leave a link in the description to the code we wrote in this video so you can take a look at the raw XML if you want. If you've gotten this far, hit the like button to let me know and subscribe so you get notified when the next video comes out, which I'm really excited for because we'll finally be able to display some meaningful data. See you in the next video. Where we left off in the last video is we created the basic layout for our COVID tracker application. Our goal in this video is to populate this graph to update the Spark view with the data we get back with the national per day data of coronavirus cases. In the code, what that means is we want to get rid of this to-do item and replace it with the actual code to render the Spark chart. I'm going to delegate the work of updating the Spark chart with our national daily data into a separate method called update display with data. This will take in as a parameter the national daily data. And then I'll have Android Studio help me to create this method. So I'll hit that red light bulb and then create the function inside of main activity. Instead of calling this parameter national daily data, I'm going to call it daily data because we're also going to reuse this method for the per state data. And this is a list of COVID data, which is a data class that we had defined earlier. There are three things that we want to do inside of this method. First, in order to render data inside of the Spark chart, we need to create a Spark adapter. Next, we want to update the radio buttons. So by default, the positive cases and maximum time range is selected. And third, we want to display the metric for the most recent day of data that we have. Let's start backwards. So the first thing we'll do is display at the bottom of the screen the metric for the most recent date. Again, I'm going to delegate the work of this into another function. I'll call this update info for date. And what we want to pass in here is a particular day of data. And the data that we want to pass in here is the most recent date. And because our data is ordered chronologically, we can pass in daily data and pass in the last element. I'll have Android Studio help us again to create this method. And we're going to call this COVID data, the parameter. So the objective of this function is to update the two text views at the bottom of the screen with the data inside of this parameter. So first is the metric. We call this TV metric label. That's referring to the text view at the bottom right of the screen. And the text attribute of this text view is going to be the number of coronavirus cases, either positive, negative, or number of deaths on that particular day. For now, because we're hard coding in positive, let's go with that. So it'll be COVID data dot positive increase. And we actually want to format this number with commas, so it's more human readable rather than just showing the raw text. In order to do that, we're going to use a convenient class called number format. So we'll call number format.getInstance.format. And the format method on number format takes in a number and it will automatically format it to include the commas and decimals. So our COVID data has a date checked attribute, which is a Java date object. We want to take that Java date object and turn it into a nice string, which looks something like May 30, 2020. So the way we'll do that is with something called simple date format. And the first parameter here is the pattern of the date. So what we care about is the month, which will be capital M's. So 3 of those letters. So for example, if it's March, it would be MAR. Then we have the particular day in the month, followed by the year. And that's denoted by the lowercase y. The next parameter is we have to pass in a locale. We'll put in locale US. And we're going to save this in a variable called output date format. Now that we have this output date format, we can use that to format the Java date object inside of our COVID data. And then this is going to be a string, which we will put into the text attribute of our text view. And we called it TV date label. Let's continue working backwards. The next step is to update the radio buttons to select the positive cases and max time radio buttons by default. This is actually very straightforward because all we need to do is specify the particular radio buttons which should be checked. That's the attribute name to indicate that it should be selected. So I'll say radio button positive, and that is checked attribute should be true. And then similarly for radio button max. Let's run the app now and see how it looks. So you can see, as soon as the network request to fetch the national daily data came back, then we execute the logic inside of the update display with data method. And that was what is updating the bottom text views with the particular date, along with the metric, and also these radio buttons. Finally, the last thing we'll do is create a new Spark adapter, which will instruct the Spark view in our layout how to render the data contained inside of this list of COVID data. So I'm going to pretend like we already have the Spark adapter class. I'm going to call it COVID Spark adapter, and we're going to construct a new instance of this COVID Spark adapter. And this will take in the constructor, the list of daily data that we have. We'll save this into a local variable called adapter. And now I'll tap on this red light bulb and have Android Studio help us to create this class. We'll extract it to a separate file in the same package, which is fine. We can leave the parameter name as daily data. And we can see that this file did indeed get generated inside of the same directory, same package where main activity is located. So we have this COVID Spark adapter. This COVID Spark adapter has to be a subclass or has to inherit from the Spark adapter class, which came in from the open source library. So we're going to put a colon here and say Spark adapter. And we'll need to import this. And you can see that it does come in from the Robinhood library. And now there's a red underline under the declaration, the class COVID Spark adapter. If we tap on the red light bulb, we can see how to fix the problem, which is by implementing these 3 members. Spark adapter is an abstract class, so we need to provide an implementation for these 3 methods. And if we tap on OK, Android Studio helps us by automatically defining these 3 methods with the proper parameter and return type. Because we passed in the daily data in the constructor, it's straightforward to implement each of these 3 methods. So I'm going to first change the daily data to be a private member variable. So I'm going to call it a private val. The easiest method is getCount, because this is simply going to be the size of the list. So because it's a one-line statement, we can use this nice feature in Kotlin to get rid of the method body and just say getCount is equal to daily data.size. The idea of getItem is that given an index, which is a position in the list of data, we would like to return any, which means a generic object, which represents the data object at that position. So again, this is actually one line. We can just index into the list of daily data. So I'm going to get rid of the body of the function and say getItem at that particular index is equal to daily data at index. Finally is getY. And the idea here is that given a particular position in the graph, we want to retrieve the corresponding value at that position. Right now, we're only going to be graphing the number of positive cases per day. So given an index, we can grab the corresponding COVID data at that position, I'm going to put that into a local variable called chosen day data. And then our job is simply to return the positive increase, that attribute, on that COVID data. The return type of getY is a float, but this attribute is of type int. And so to turn it into a float, we just call the toFloat method. So we've defined the basic working version of the Spark adapter. We can go back into main activity, the error goes away, and now we have one more line to write, which is we have to grab a reference to the Spark view and set the adapter property to be the adapter that we just defined. That's it. Let's try it out. When the app boots up, you can see that we are graphing now in this Spark chart the number of positive coronavirus cases nationwide over the maximum time range. And at the bottom of our application, we're showing the particular data, the particular metric for the most recent day. Now that we have the ability to show one chart on the screen, we're going to extend this functionality so that we're able to respond to changes in a radio button click. We'll do that in the next video. If you've gotten this far, drop a comment and let me know how it's going. Don't forget to subscribe so you know when the next video comes out, and I'll see you then. Bye. In this video, our goal is to make this Spark line chart more interactive so that we update it when the user taps on any one of these radio buttons for either selecting a different metric to show or selecting a different timescale. The way we'll go about doing this is to map the radio button selection to an enum which represents the metric or the timescale. So I'm going to create a new class called chart options. And this chart options KT file will encapsulate all the knowledge about the different ways we could render this chart, this Spark chart. And there's going to be two enums inside of this chart options class. The first will be for the metric being shown. And there are three possible metrics that we can show on the graph. One is negative cases of coronavirus. One is positive cases of coronavirus. And then lastly is the number of deaths. The other enum we'll define here is the bottom row of radio buttons, which are the time period over which the chart should display data. We're going to call this enum class timescale. And this enum is going to have an associated integer, which represents how many days does this timescale represent. So I'm going to call this val num days, and this is going to be an integer. So there are three possible options in the bottom row of radio buttons. One is for 1 week of data, and the corresponding enum is 7 days for that. Then we have 1 month, and we're going to assume that 1 month is always 30 days. And then finally is maximum, which means show the maximum amount of data possible. We don't know ahead of time the number of days associated with the maximum time, so we're going to instead put a special value, which is going to be -1. The combination of these two enums, metric and timescale, cover all the possible ways that our chart, our Spark chart, could be rendering data. There's also a notion of our chart having a certain state. Our chart has to be displaying one of these metrics, and it has to be displaying data over exactly one of these three timescales. That state will live inside of the adapter for our chart. So inside of the adapter class, I'm going to define two variables here, one for the metric, and this is going to be by default showing the positive cases. And notice that this is a var, not a val, because we do expect that this metric will change over time as the user taps on one of those radio buttons in the top group. And there's one more variable, which is the number of days ago. And this is by default going to be the maximum timescale. Now that we've defined these two variables, our adapter is now aware of what it should be rendering in the Spark chart. So in the function getY, which returns a float of the corresponding metric value at this position, at index, instead of always returning the positive cases of coronavirus, we should instead check the value of the metric variable. I'm going to use the when construct in Kotlin, and we'll return a different value depending on the metric. I'll say return when, and depending on the metric, we'll do something different. When the metric is negative, then we want to return the negative increase dot to float. When the metric is positive, we want to do something quite similar, except this should be positive increase. And then when the metric is death, we want to report the number of deaths on that particular day. And then later on, we're going to use days ago in another function that we override on the adapter. There's one more place back in main activity where we hard-coded in the assumption of always returning the positive number of coronavirus cases. So here as well, in this update info for date method, we want to again check the metric enum in our adapter and then return the corresponding metric. So in order to have access to the adapter inside of this method, instead of defining it locally here, I would like to make it a property. So I'm going to delete the val, and now Android Studio will show me this red light bulb, and I can use Android Studio to create the property for me. So now we have this adapter, and right here, we want to do something quite similar. So val num cases should be, again, something which is based on the adapter dot the metric. And if the metric is negative, then we want to return the COVID data, which is a parameter passed in here. We want to display the negative increase attribute of this COVID data class. And then in the case of positive, we want to show positive increase. And then finally, in the case of death, we want to show the number of increases in the number of deaths. So instead of always placing this value in, we can instead show num cases. We haven't made any functional differences in the app yet because we haven't added any event listeners for when the radio buttons are changed. So all that logic for listening to changes in any of the UI elements, we're going to put all that in a function called setup event listeners. I'll call that method right here, setup event listeners. And we'll define this method inside of main activity. The reason I'm calling this method here is because we only want to make the UI interactive when there is actually data to show. So as soon as we get the success from our API call to get the national data, that's when we want to hook up the radio buttons and the ability to actually scrub on the graph. Before that, it doesn't make sense. So in setup event listeners, there's two things we want to do. First is we want to add a listener for the user scrubbing on the chart. And second, we'd like to respond to radio button selected events. I'll leave it to do for the second item because we'll get to that later. In order to allow the user to scrub on the chart, which basically means hold down on the chart and drag their finger over it, the first thing we need to do is set the isScrub enabled attribute to be true. And then we need to set a scrub listener on the Spark view. And as you can see here, the parameter that we are provided in this set scrub listener is a value, which is a value corresponding to one data object in the chart. In particular, if we go back to the adapter, you can see that the item data that we get back is going to be the return value of this function getItem. And we're returning back the COVID data element at that position. So going back into main activity, I'm going to call the parameter here item data. And then the job here is in the body of this function, which will be invoked for us, we want to update the UI with this information. As a sanity check, one thing we can do is just check if the item data is indeed COVID data, which it should be because that's the only thing we're returning, but this is kind of a safety check. Then we can call the method we already defined, update info for date, with this item data. So we're going to be updating that bottom UI component to show the date and the metric at that date. Let's run this. So now if I hold down on the chart and I move along, you can see that I am able to have this vertical line show up. And as I move it along, you can see the values at the bottom get updated. So on April 18th, I'm able to see exactly the number of positive coronavirus cases nationwide. And this makes our application a lot more useful because we're giving the user an ability to drill down into specific days. The last thing we'll do before hooking up the event listener for radio button taps is go back into the COVID Spark adapter and make use of this days ago property. The idea of days ago is that we want to change the timescale of our graph to only show that amount of data. The way we'll do this is by overriding one more method in the Spark adapter class. It's called getDataBounds. Super.getDataBounds, this invocation of the parent method, which already defines this, is going to return to us a rectf, or a rectangle composed of float coordinates. So I'm going to capture that super value into a local variable called bounds. And the idea here is that this rectangle defined by bounds will dictate what exactly is shown in our Spark chart. If you wanted to shorten or expand the amount of data shown in the chart, all we need to do is update the left end of this bounds rectangle. So we can say bounds.left is equal to, instead of the whole data, which is count from basically invoking this function getCount, instead of showing the whole amount, we'll say count minus 7, which means chop off everything except the last 7 days worth of data, the most recent 7 days worth of data. And this needs to be a float, so we would have to call toFloat here. Then we can return these modified bounds. Of course, we don't always want to subtract 7 from the count and only show the last 7 elements of the list. Instead, we'd like to change it based on this days ago property. Instead of having 7 here, we want to get the days ago variable, get the corresponding num days property out of that enum, and turn that into a float. This will work in the case of looking at the last 1 week or 1 month of data, because the corresponding value of num days will be 7 or 30. However, when the max option is selected, instead of reducing the amount of data shown by subtracting from count, we would instead like to show all the data. So that's a special case where we'll say if days ago is not equal to timescale.max, only then do we want to reduce the amount of data shown. So if days ago is max scale, bounds will actually be unchanged, which is what we want. So now we're finished laying the groundwork for being able to respond to when the user taps on the radio buttons. We simply need to modify the metric or days ago enum inside of the adapter. Now we can go back into main activity and write the logic to respond to radio button selected events. So let me remove the to do because we're actually going to complete this item right now. There are 2 radio button groups that we're going to respond to. The first is the set of radio buttons on the bottom of the screen, which is for selecting the time. So radio group time selection. And we're going to set onChecked change listener. So this is going to invoke the body of this function whenever one of the radio buttons in that bottom group has been selected. This method that's going to get invoked has 2 parameters, one which is group, which we don't care about. So I'm going to change that name to be a underscore, followed by a checked ID. And the checked ID is the ID of the radio button that was selected. So the only thing that really needs to happen here is we need to update the days ago property in our Spark adapter to be the corresponding value when one of the radio buttons is tapped on. So for example, if I tapped on the radio button for 1 week, I should set adapter.daysago to be timescale.week. So rather than hard coding it, of course, we should do this contingent upon the value of checked ID. So we'll use the when construct. I'll say when checked ID. And if the checked ID is r.id.radio button week, then we'll map that to timescale.week. If it's r.id.radio button month, then we'll set the timescale to be month. And then otherwise, the timescale is max. Once we've updated the days ago, the only other thing we need to do is notify the adapter that the underlying data has changed. So the adapter knows to re-render itself. The other radio button group is at the top of the screen for displaying a metric. So we'll do something quite similar. Radio group metric selection dot set onChecked change listener. We don't care about the group, but we do care about the checked ID. So I'm going to do another when based on the checked ID. If the radio button is positive, then we want to update the display metric to be positive. So I'm going to actually delegate the work of updating the display metric into a method called updateDisplayMetric. And I'll pass in positive here. Let's also do the same thing for the radio button negative. And then finally for death, radio button death. Let's define this method now. The only thing that needs to happen here is something quite similar. We're going to update the metric variable in the adapter to be the selected metric, and then we'll notify the adapter that the dataset has changed. Let's try it. So by default, we're seeing the nationwide number of positive coronavirus cases over the maximum timescale. If I change the metric to be negative, you can see that we are seeing a different chart, and similarly with the number of deaths. I can also do the same thing for showing only a certain period of data. So 1 month, you can see that I'm only seeing that last segment, and then week, I only have 7 data points being shown here. So that looks like it's working. In the next video, we'll make a few improvements to the UI when a radio button is selected, and we'll add in a spinner or a drop-down component at the top of the screen, which will allow the user to look at the data for a particular state. If you have any questions about what we've done so far, feel free to drop a comment and I'll help as much as I can. Don't forget to like and subscribe, and I'll see you in the next video. There are 2 things I'd like to do in this video. One is I'd like to make some improvements of what happens when I change either the metric shown for the Spark chart or the timescale shown. And second, I'd like to include a drop-down or a spinner component at the top of the screen, which will show all the states. And if the user selects a particular state, we should update the data shown in the chart for all the COVID-19 cases of that state. So first, one thing you'll notice is that when I change the metric being shown in the graph, this bottom component, this text view, doesn't get updated. So we're actually showing wrong information here, right? This 20,000 is for the number of positive cases of coronavirus on this particular day and not the number of deaths. So this should really be updated when this metric gets updated. The way we'll fix this is by adding some logic in this method, update display metric. This method is invoked every time the user changes the metric shown on the graph. So what the logic we have here is doing is updating the metric on the adapter. We'd also like to reset the number and the date shown in the bottom text views. So really what we'd like to do is call the method that we wrote a while ago called update info for date. So the idea here is that we want to pass in the last COVID data object and have this bottom component show the most recent data, the last day of data that we have, along with the metric corresponding to the metric passed in here. And that logic is already built inside of the update info for data class. So you can see that we're already checking the adapter metric, so we're going to show the right value. The question now is, how do we know what to pass in here? The issue is that we need to know what data is currently being displayed in the Spark view. If the data being shown is a national data, then we can take the last element of that list of COVID data representing the national coronavirus data and pass that into update info for date. But if we're showing a particular state's data, we need to know what state we're showing and grab the last day's worth of data for that state and pass that in. So we need to have some way of knowing what is being shown currently. To do that, we're going to add one more property or member variable inside of main activity. I'm going to define a property called currently shown data. And this will hold on to the data that's currently being displayed inside of the Spark view. And the reason I'm assigning the value here is because this method, update display with data, takes in the list of data which is being shown in the Spark view. So we know that this method has to be called at the beginning and every time that the data for the Spark view has changed. Currently shown data is going to be equal to exactly the parameter passed into update display data. Now, Android Studio can help us to define this property. Create property currently shown data. And now we can go back to update info for date and then pass in the last element of the currently shown data. One more thing I'd like to do before we try this out is a quick design improvement. Based on the metric being shown, we can display a different color for the chart. So I'm going to add a comment here which says update the color of the chart. And what we want is there's an attribute on the Spark view called line color. And we want to set this to be equal to some color integer. The way you get a color integer is you can say context compat.getColor, and you can pass in context, which is this, and a color resource. So there are some predefined color resources like r.color. Let's say color accent. This will give us back a color int. And I'm going to actually add an annotation here to make it obvious that this variable is of type color int. So we can pass in color int here. And then also we can update the text view which represents the metric. So we call that TV metric label, and we're going to set the text color int. So now, based on the metric, we want to show a different color here, rather than just the color accent. So here are the colors that I picked out, which I thought were intuitive for each of the metric types. Negative cases is green, positive cases is this orange color, and number of deaths is this red color. So back in Android Studio, I'm going to paste in those hexadecimal values inside of the colored resource file. So instead of resources values, you should already have a colors.xml, and we're going to add 3 more colors here. One will be color negative, and then this will have a value of the green color. Then we'll have color positive. This has the orange value. And finally, we'll have one more color representing the death metric. This has that red value. So now that we've defined these 3 colors, we can go back here and again use the when construct, the when statement in Kotlin. We're going to define a colored resource, which is the result of this when statement. Inside of the when statement, for each metric, we'll map it to the color resource that we had. So for example, metric negative will map to r.color negative, positive will be color positive, and death will be color death. Now we can use the color res value when we're obtaining the color int using context compat.getColor. And finally, last thing we can do before we run this is inside of this method, update display with data, we're calling update info for date. We're already calling this method inside of update display metric, and we're actually doing other useful things such as updating the line color. So rather than calling update info for date, I'm instead going to call update display metric and pass in metric positive, because that's always going to be the default metric shown. Let's try it. So now you can see when we run the app initially, we are again seeing the positive cases of coronavirus over the maximum time scale, but we have this nice color applied to it, this orange color. If I change this to be death, we can see it gets updated to red. And importantly, the text here at the bottom showing the exact metric for the most recent day has been updated to reflect the chosen metric. The last major piece of functionality for our app is allowing the user to select which state they want to see data for. So back in main activity, this is corresponding to this to-do item that we had left in one of the prior videos. So we're finally going to do this. I'm going to remove the to-do, and I'm going to delegate the work of updating the spinner with the state names into a method called update spinner with state data. And this function is going to take in one parameter, which is the list of all the states to show. And that will simply be the key set of this map. So if you recall, the per state daily data is a map of each key being a state and the value being all of the COVID data for every day of that state. So now we can have Android Studio help us to define this method. I'll define it in main activity, and I'll have the parameter be called state names. And this is of type set of string. The objective here is, given these state names, which are a set, we want to turn that into an ordered list, and we're going to take that ordered list and pass that in as the input to our dropdown component. So first, let's turn our set into an ordered list where we're alphabetizing all of the states. So we'll call state names.toMutablelist so we can actually change and mutate the contents of this list. We'll call this variable state abbreviation list, and it will contain the abbreviations for all 50 states plus several US territories. And we want to alphabetize this list. So we want states like Alaska or Alabama to show up at the top, and states like Wyoming to show up at the very end of this dropdown. So we'll call .sort, and then we also want to have one special entry in the state abbreviation list, which is to represent the national data, right? We're not going to get that in the set of strings passed in here because this only contains state names, so we're going to have to add it manually right here. And this is going to be the very first element in our list. So we'll add this at position 0, and I'm going to have a special entry which is called all states, which basically means I want to see the national data. So again, Android Studio will help us to define this variable, all states, And this is going to have a value, a hard-coded value of all nationwide. And I'm actually going to define this outside because I can make this a const. So what we want to do next is take this ordered state abbreviation list data and add that as the data source to our spinner. Next, we need to add the spinner into our UI. So going into activity main.xml, we would like to be able to add a spinner component at the very top of this layout that we're building. I'm not a big fan of the built-in Android component for this, which is this spinner component. I think it's really hard to use and it doesn't look that good. Instead, we're going to use a library called NiceSpinner. And this is easier to work with, and in my opinion, it looks better. So let's go down first to how to include this library into our project. So inside of the build.gradle file, we need to add a dependency like normal, but also we should add this section about repositories. So I'm going to go into Android Studio, go into the build.gradle file, which is located inside of the app module. And you probably won't have a repository section here. So right after we added compile options, let's add repositories. And we want to add this Maven repository. So I'm going to copy this line and paste that in. And now we should be able to add the dependency. I'm going to copy this line and paste it in here. Let's tap on sync now, and hopefully we're able to download this library properly. Looks like it succeeded. So now we can go back into activity main and we can include it in this area that we allocated for it. To do this, I'm going to go back into the code view of our layout. And right here is the label which describes what this spinner is for. I'm going to create another component which is called spinner, and it should be NiceSpinner. We'll set the layout width to be 0 dp because we want this NiceSpinner to take up as much room as possible. The height can be wrap content. And we're also going to add a margin start and end. There's a few other properties we can add in here. Ellipsize, we're going to ellipsize in the end. And the maximum number of lines will be 1. And then the text appearance of what we're showing should be large. And now our job is we need to constrain this view appropriately. For the horizontal constraint, we want the left end of the spinner to be up against the right end of the select state text view. So I'm going to say constraint start is to the end of the TV select state. And then the end constraint is going to be to the end of the parent, because we want it to go to the end of the screen. For the vertical constraint, we're going to have the top and bottom of the spinner be equivalent to the top and bottom of the select state text view, which is to the left. So bottom of, and then we want to pass in TV select state, and then something quite similar for the top. And then one last attribute that I forgot to add is something called pop-up text alignment. And I'm going to put start here, just so that in the dropdown, all of the states are left aligned or start aligned. So if I go into the design tab now, we should see that there is a space allocated for the spinner. One thing we can do here is just give this an ID, because we'll need to refer to it in our mainActivity.kotlin file. We'll call it spinner select. Now we can go back into main activity and let's reference this spinner that we just added. So I'll say spinner select dot attach data source, and we'll pass in the state abbreviation list. The last thing we need to do to hook it all up is we'd like to be notified when the user has selected another state from the dropdown. So on the spinner select widget, we're going to add a set on spinner item selected listener. And this takes in 4 parameters. The only ones that we care about are the parent and the position. So I'm going to put an underscore in for the other params. And this method will be invoked every time a new item in this dropdown is selected. So in order to get the selected state, we're going to say parent dot get item at position, and we'll pass in position. And we know that this is going to be of type string. our data source for the spinner is a list of string. I'm going to cast this as a string and save this as the selected state. Now we'd like to get the corresponding daily list of COVID data for that state. So I'll say per state daily data, and then we'll look inside the map to pull out all of the data relevant to that state. This is going to be val selected data. The only thing we need to be careful about here is that if the selected state from the dropdown is the all option, which is I want to see the data nationally, then that element won't exist in the per state daily data, and we're going to get a null value here. So if that happens, we can use this question mark colon operator to say if the value here was null, then we would instead like to assign the value of national daily data to this variable. Now that we have selected data, which is our list of COVID data across all the days available, we can now simply call the method we already have called update display with data with selected data. That should be it. Let's try it out. Perfect. So now we're able to see this dropdown, and by default the all option is selected, which means we're seeing data nationally, and then all these state abbreviations are what we're getting back from the API. So for example, I might look at the California data, which is CA, and we can see that the data does get updated. So the text view down here to show the exact metric value is showing something significantly smaller, which is for California. And then if I choose different metrics, I'm again seeing the California specific data. And the same functionality applies across all states. I can scrub on the Spark view, I can change the timescale, and I can choose any metric that I want. If you've gotten this far, drop a comment to let me know so I can congratulate you on building out all the functionality for our application. In the next video, we're going to make a couple design improvements. For example, we're going to use one more Robinhood library called Ticker in order to animate changes to this text view, and we'll do a few other design and color improvements in the app. Don't forget to subscribe so you can get notified when the next part comes out, and I'll see you in a little bit. Bye. At this point, we're done with all the functionality for our app. In this video, we're going to go through a couple of really easy and high impact design improvements. First, in order to really make our app feel like the Robinhood stock trading app, we're going to use a library called Ticker in order to animate changes into this text view. Here's the GitHub page for Robinhood Ticker, and you can kind of see what this looks like in this GIF. We're going to have the same effect for our text view. So if you scroll down, all we need to do to include this is add this into our build.gradle file. So this is again going to go into the build.gradle in the app module, tap on sync now, and then let's go back to GitHub. And you can see it's really straightforward to use this. Instead of the text view, we just need to replace that with a ticker view. So let's go back to Android Studio, go into activity main, and that component that we wanted to replace, instead of just being a text view, we would like this to be a ticker view. So go into the code view, go to the very bottom, and this is what we want to replace. So I'll say ticker view here. And then I also want to just update the ID and make this ticker view, just so it's obvious that this is the Robinhood UI component, ticker view. Now, the only thing we need to do in order to properly use the ticker view library is go into main activity, and we need to set a character list on the ticker view. So in the method for setting up the event listeners, let's add one more line here, which is for the ticker view, and we're going to set the character list. There's a predefined character list called ticker utils dot provide number list, because we're going to be animating over numbers. So if we try this now, so I'm showing positive cases now. I go into the number of deaths. So you can see how the ticker view did animate in this really nice way. And same thing with negative cases. And if I scrub over the Spark view, you can see as I scroll, we're getting that really nice feedback that this number is changing. One other quick design improvement we can do is to add a background shading color behind the Spark view and the time radio group. The reason this is valuable is it provides segmentation into our layout, and it gives a hint to the user about which components are related to each other. The way we'll go about doing this is by adding some padding and margin between the Spark View and the radio group time selection, and then adding a background color to those two components. So going into activity main, on this radio group, which sits below the Spark View, then we'll add a margin top of 16 dp, and we'll also add a padding bottom of 8 dp. And for the Spark View, we are going to add a padding on the top of 16 dp along with a padding bottom of 8 dp. And these are the two components, the Spark View and the radio group time selection, on which we're going to have a background color. So I'm going to assign a background, and for now it'll just be color primary, but we're going to update this in just a bit once we define the color. So I'm going to actually call this color background shade, and then have the same color be defined here. And then let's have Android Studio help us create a color value resource. The resource value I'm going to put in here is this very light gray, light blue color that I found. And basically what that did, if I command click in the color background shade, is it added one more color resource in our colors.xml file. So if we try this now you can see we have this background color behind the Spark View and the time selection, and that makes it easier to comprehend what we're looking at. The last major design improvement I would like to make in this video is to improve the UI of these radio buttons in our application. So the default radio button UI on Android, I think, is pretty ugly. So we're going to modify it so it looks and feels like a button. I have a separate video which talks about a few of the aspects of what we're about to do, so I'll leave a link to that if you're interested. But the idea is that we're going to remove this circle icon next to the radio button and add a background drawable, which is a shape drawable, behind each of these radio buttons. So first, let's fix the styling for a single radio button. How about this negative radio button? And then we'll think about how can we apply that style to all radio buttons in our application. And I use the word styling deliberately because instead of adding these attributes directly onto the radio button, I instead am going to define a style and apply the style onto this radio button. So inside of the styles.xml file, which you should already have in the values directory in resources, I'm going to open that up. We're going to define a new style here. And the name, we'll call it custom radio button. Styles can have parents, and parents are basically where are you inheriting all the different attributes of styles from. And you can see that Android Studio is suggesting for us that we have the parent be widget app compat compound button radio button, which is what we're going to pick. And inside of this style tag is where we're going to define various attributes. In order to remove that circle that shows up by default on the radio button, we're going to override the Android button item, and we're going to set this to a value of null. Also, why don't we set the text style of the radio button to be bold. So I'm going to add this style, this custom radio button style, on the negative radio button that we had. And so I'm going to add the style attribute and then reference the custom radio button style. So if we try this now, we should hopefully no longer see the circle next to the negative icon. Yeah, and you can see that is indeed the case. And we're also bolding the font like we expect. Now going back into styles.xml, let's add one more attribute onto the custom radio button for the background. And let's define a drawable here. And we're going to create a brand new drawable. For now, I'll just call this button default. And then now let's have Android Studio help us to create a drawable resource file, which is named appropriately. The root element, let's have that be shape, and then tap on OK. And so here is where we're going to define different attributes of the background for our radio button. Things like the corner radius, the padding, the shape, like whether you want it to be a square or oval, etc. So there's a few different attributes we're going to define here. One which is padding, and we're going to have the padding be on all sides 12 dp. then one more attribute we're going to have is a radius of 4 dp, a corner radius of 4 dp. So if we go back into styles.xml, the error has gone away, and now we should be able to see this button default as the background for our radio button. But what we really would like is to change the background based on the state of the button. If the radio button has been selected or in the checked state, that means it's having an impact on what is being rendered in the Spark view. We'd like to show it in a different way compared to in this default way, just button default. The way you can do this is through something called a state list drawable. So we're going to have one more state list, which is of a selector type, and the selector is basically going to tell us whether to use one background resource file or another background resource, depending on the state of the underlying widget, or radio button in this case. So I'm going to define another drawable resource and call this button background. And Android Studio will help us to create a drawable resource file, but this time the root element will be a selector. And the reason we want this to be a selector is because this button background.xml is going to select which background we actually want to apply on the radio button depending on the state. We only have really two states we care about for the radio button. One which is the default, and so I'm going to put that at the bottom of the file, and that's what we already defined, button default. And then if the button is in the checked state, that's the terminology for radio buttons. If the state checked is true, we want to create another drawable for what the button should look like at that point. So I'll say Android drawable, and this is going to be drawable button checked. Let's have Android Studio help us. This is going to also be of type shape. And it'll be quite similar to our previous button default. So I'm going to copy over everything here. The only thing that will be different is we're going to have a solid color background in the case that the radio button has been selected. We're going to define this. We'll call it color selected background. And let's tap on the red light bulb and create a color value resource. So I'm going to put in this gray value that I found. And then I noticed that I misspelled use Android Studio to help you refactor this. So back in button background, let's add the closing tag here and let's try it out. So by default, we're not really seeing any difference, but now when we tap on the radio button, you can see that we are swapping out the background to this darker color in the back. What we'd also like to do is change the text color. So we're going to take a very similar approach for that. Back in styles.xml, we're going to define another item which is called text color, and this is going to be a color state list resource. So I'm going to call this color button text, and we're going to create a new color resource file, and the root element will be a selector. So it's the same concept as a drawable state list resource. We're also going to have color state list resources. Here by default, if the radio button is not selected, we're going to go into the default case and we're going to pick color selected background. So we're going to do the opposite of what we're doing in the case of the button. So by default, we're going to have the selected background color, and otherwise we're going to just use white. The state checked is true, then the color becomes white. Let's try it. So I tap on the negative radio button and you can see that we are able to properly swap out the text color to make it white and make the background that gray color. So the next step is we'd like to apply the same style to each of the 6 radio buttons in our app. So one approach is we could go back into activity main and then copy over this style line in every single radio button. But then in the future, if we add other radio buttons, we'll have to keep remembering to add this style line. Instead, we're actually going to make this part of the theme. So we don't even need to include it in any radio button. I'm going to get rid of this line. Going back into styles.xml, this style app theme defines the base application theme, and you can customize it here. So there is a property called radio button style. So we're going to add one more item, which is Android radio button style. And we're going to reference the custom radio button style. Let's try it. So now, if we've done the job correctly, all 6 radio buttons should be updated to include this new style. There, you can see we are seeing that, which is great. Next video is the last video in the series. I'm going to do one super quick design improvement, and then we'll recap everything we've built. If you've liked what you've built so far, drop me a like and subscribe, and I'll see you in the next video. Bye. Welcome to the very last video in the COVID tracking project series. So I want to start out by just doing a really quick design improvement to align the project that we have here with what I showed you in the demo in the very beginning. So I'm going to update the color scheme of the action bar color here and the color shown in this notification window. Both of these colors are defined in colors.xml, color primary dark, and color primary. So the color primary, I'm going to actually make it be identical to color selected background. And color primary dark, I'm going to make it a slightly darker gray. And because color selected background is the same as color primary, I'm actually going to just make this a reference to color primary. And one last thing, in order to make it pixel perfect with the original demo app, is if we go into activity main, we can add a margin top on the Spark view of 8 dp. Let's try it. Awesome, so now you can see that we've faded out and made the action bar less noticeable so that the main attraction of our app is the Spark view and the metric being shown. Finally, the very last code change we're going to make in this project is updating the text that's shown in the action bar. Instead of saying COVID tracker, I wanted to say COVID-19 cases per day so that the user has an idea of what they're looking at. So in main activity, inside of onCreate, right after the set content view, we can just say support action bar dot title is equal to, and we're going to pass in r.string.app description. The app description is a string resource that we're going to create. The resource value will be COVID-19 cases per day. Hit enter. Support action bar might be null, so I'm going to wrap that in a question mark. And we need to actually get the string value out of the string resource. And that's straightforward. We just need to say get string and pass in that resource. Let's try it. Right, and now you can see the action bar did get updated properly. There are a lot of natural extension ideas for this project. For example, right now we're only showing US data and US states, but you might be interested in, for example, the coronavirus cases in India. And that would be a really natural thing that you could build in this app by talking to a different API. Another thing you might think about is instead of showing the delta per day, we might want to see the cumulative data from the first coronavirus case up until today. And there's no way to do that now, but you might imagine having some sort of toggle. And finally, we're making a network request every time we open up the app. However, the data only gets updated once per day. And so you can imagine implementing a local database where we cache all the data. So you could implement something like a Room database in our application, store all the data, and if you don't have an internet connection, or if the API request is unnecessary, we can simply grab the data from our database. To recap, we covered a lot of ground in building out our Robinhood-style coronavirus tracking app. First, we used Retrofit to talk to the COVID tracking project, which is the API which provided all the data for our application. Next, we used 2 libraries from Robinhood in order to build out the core UI of our application. First was Spark, which helped us to graph this Spark line chart in our application and showed the growth of coronavirus cases, negative, positive, or deaths on a per day basis. And the second library was called Ticker, and that allows us to animate changes in a text view. And finally, we used another library called Nice Spinner in order to have a better looking drop-down menu, a better spinner, which shows all the state data, and when the user selects a new state, we update the UI accordingly. If you've been following along and you have your own working version of this coronavirus tracking app, I'd love to hear from you in the comments. Let me know how it went, or if you completed any extensions beyond what we built. Given that Google still isn't allowing COVID-19 tracking apps in the Play Store, I really hope that you're able to use this mobile app as a way to track the growth or hopefully the decline of coronavirus over time. I'll leave a link to the GitHub repository in the description. If you have any questions, feel free to let me know and I'll help as much as I can. Until next time, stay safe and I'll see you later. Bye.